In this video, we're going to look at some elements of design and how we apply our knowledge of nets and scale diagrams to designing. So this diagram to the right is the net of a small box used by a local jewelry store. In this scale diagram, the distance between two dots represents 1 centimeter. Okay, so that's very important. 2 dots is 1 centimeter. So we have been writing that like this. Okay. Now, to answer this question, what is the minimum size piece of paper needed to cut out the net in order to make the object? We're going to look at all of the different dimensions of this box. And if you were having trouble with this at all, it would be worth your time to actually cut out the box so you could picture how it gets folded into a box. So you could always take your paper and you could do a little cutout of it around all of the edges, around the outsides only. Okay, so each square is 1 centimeter, so that makes it fairly straightforward. So first thing I want to do is just look at this line right here. So it is 6 dots, so that would of course be 6 centimeters. Okay, obviously this one over here is the exact same. And this one here, and this one here. Okay, and this one right here is 4 squares, so that one is 4 centimeters. And the same as this one, and any of these ones. Now, if you can see that this side is folding up, this is the front, and this same side right here is folding up, and it's sort of the back, if you like. And this part right here is what I'm going to call the bottom. And then hopefully you can see how this side piece on the right here is folding up, and this will eventually become the top. And these are the sides. And as it folds up, this distance right here represents the height of the box, which is 2 centimeters. Okay, so this is the height of the box. We can call the 6 centimeters the length of the box, and the 4 centimeters, let's say, the width of the box. And I do want to fold it just so you can get a sense of what it looks like, right? So this is our bottom or our top of our box. Okay. Here is our front. This is our top, but of course the bottom looks the same. And this is our sides or our width, right? And so we have dimensions of 6 centimeters by 4 centimeters the width by 2 centimeters for the height. So now let's look at the size of paper we need. The size of paper you need obviously would be this by this, right? This green piece of paper. So now using the scale diagram, you just want to count that up. So this side length here is 8, which translates to 8 centimeters. And this side length right here is 16 boxes, which translates to 16 centimeters. Now all of these should have multiplications, meaning we would want it to be 16 centimeters by 8 centimeters. Now, using some of our formulas from the past, and there is a formula sheet posted as well, we are talking about a rectangular prism or a box. So the volume of the box is simply length times width times height, which I drew it out nicely for you, so you should be able to see it. It should make sense. It's 6 times 4 times 2. Right? So that would give us 48, and our units are cubic units, so centimeters cubed. Now, for the surface area, you're welcome to look at the formula. I also find it helpful to look at the net, right? So let's go through the different sides that we had. So first of all, we have our top and our bottom, right? And those two are the same, so I'm going to say 2, and then we're going to do the top and the bottom area. Then we have our front and a back, and those are the same, so we have 2 times whatever the area of our front and our back sides are, and then we have 2 of what I'm going to call our sides, the ones in red that I shaded. So in total, there are 6 surfaces of this box, 6 sides that you could touch, right? Okay, so let's put some numbers in. So our top and our bottom, right, the dimensions of those are 6 by 4. It doesn't matter which order you multiply that in. The front and the back, the dimensions of those are 6 by 2. Again, doesn't matter which order you write those in. And our sides, hopefully you can see it, they are 4 by 2. So you just need to do a little bit of simplifying here, do your best, pause the video, and see if you can get it correct on your own. And so that gives us a total of 88, and we're talking about area here. Surface area is just area of all the surfaces, so the units are centimeters squared. So now I want you to see if you can draw this box. So the jewelry store has another box. Here are its dimensions, and I want you to draw a scale net using the ideas that we just went through. So pause the video, see if you can do it by yourself. Okay, check out how you did and make sure you come to ask any questions if you have any troubles with this. In this next part of the video, I just want to review the idea of scale models, scale diagrams with you. So here I have an example of, let's say I had a model car that was 25 centimeters long, and it tells me that the model is constructed to a scale of 1 to 14. So that's how you say that. So this means for every 1 centimeter in the model, it actually represents 14 centimeters in real life. Okay, and the units that you're comparing do need to match. Okay, so what is the length of the actual car in centimeters? So we're going to take our 25 centimeters and we're going to multiply it by, you can do the 14 centimeters in real life if you like, over the 1 centimeter model. That's what that's talking about. Okay, just to get an idea of your units here, since this centimeters is the model and this is the model, those will cancel out. So really you're just doing 25 times 14, okay? And of course when I punch that in, I get 350 centimeters. So in real life, this car is meant to be 350 centimeters. Now, of course, I don't really want to measure a car in centimeters. I would more likely measure that in meters. And so I just want to remind you then that 100 centimeters equals a meter. And so if we're talking about 350 centimeters, the length of the car in meters would actually be 3.5 meters. Okay, and if you like, you can take your 350 centimeters, you can multiply it by 1 meter over 100 centimeters. So ultimately, you end up dividing 350 by 100, and your units of centimeters cancel out. Okay? So I want you to try some of these, and then, of course, check your answer. So there's a couple practice questions right here, and then one that brings in drawing a scale model on paper as well. And the last thing that's in this package is this concept or idea of 4 floor plans. So a bungalow is designed for a small lot. The floor plan of the house must fit into a rectangle that is 26 by 45 feet, okay? So the idea is on this scale that it's drawn so that it's 26 by 45 feet. You're going to check that. And here's the possible specifications for all of the different rooms in this bungalow. And one prepared floor plan looks like this, okay? And it has a scale such that the distance between 2 dots represents 2 feet. So that's this idea that we've been working with where that represents 2 feet. Okay, so on your own, I think you can do this on your own. Think of it as sort of a little bit of a challenge. You can then submit this in the appropriate assignment folder if you would like as an extra thing that you could do to help your mark. So on your own, you're going to determine the square footage of each room based on this scale diagram and follow through with that calculation. And then you're going to see if you can prepare an alternate floor plan to present the buyer. Okay, so again, meeting all of the rooms need to meet these specifications. Okay, that's the idea here. So go ahead, try that on your own. You can submit that if you would like. So this is an optional task that you can work on as sort of an extra into your mark. So go ahead and try that if you have time.